Hello friends, today we are going to learn an important topic from your first chapter, electric power. Okay, so what is electric power? Electric power means it is the amount of energy consumed by any electric appliance in a unit time, which means in 1 second how much energy or how much current is used to perform or used to work that device. That is called electric power. Okay, so how we can write this equation? Power which is equal to work done by time. So what does it mean, work done by time? By definition we are saying that amount of energy, but by equation we are saying that work done by time. Some of you have some kind of confusion. What is this difference? Right. So actually to perform a work we need energy. Right. So we can rewrite this equation as power which is equal to energy consumed by time. So both are same, either work done by time or energy by time. Actually power is the rate of work done. Okay, so what kind of work is doing in an electric current or in electricity, what kind of work is done or who is doing that work? So we know that current is flow of charge, right? So in electricity the work is to do for continuous flow of electron. So to continuous flow of electron there need to be a work. Okay, so who is doing this work? Potential difference. So voltage supply is doing that work. So we can write electric power which is equal to work done by time. So how we can write the unit? Now we are going to write the unit of electric power. P is equal to W by T, which means work done by T, time. So work done, what is the unit of work done? Which is joule, right? Joule by time. So we can write this as joule by second. So joule by second, this is called watt. This is called watt. We can indicate this letter as W. Okay, this is the unit of power. So we studied that the unit of power which is equal to joule by second, which is equal to watt. Which is equal to watt. Maybe in your exam you'll get a question like define 1 watt. How to define 1 watt? Which is nothing but 1 joule of work done in 1 second. That is called 1 watt. Okay, so from this itself we can define. Now what is the basic unit of power? So there are some higher unit which is kilowatt and megawatt. Kilowatt and megawatt. So here you have to be careful. Maybe in your exam you'll get the quantity or the power in terms of kilowatt or megawatt. So what you have to do, you have to convert it into watt. How to convert? Actually 1 kilowatt which is equal to 1000 watt. 1 kilowatt which is equal to 1000 watt. So you can write this as 10 raised to 3 watt. Okay, now how much is megawatt? 1 megawatt which is equal to 1 kilowatt. 1 megawatt which is equal to 1000 kilowatt. So how much is this? We can write this as 10 raised to 6 watt. Okay, so kilowatt, 1 kilowatt is equal to 1000 watt. Here megawatt, 1 megawatt is equal to 10 raised to 6 watt. Okay, now we are going to derive some equations for power. According to Joule's law, you know that heat generated or the work done which is equal to I square RT, right? What was Joule's law? Just try to recollect. H is equal to I square RT. So we can write it as H is equal to work done which is equal to I square RT. So we have the equation for power. What was our equation? Power which is equal to work done by time. So we can substitute this. What we'll get? H by T, because heat generated by time. So now just try to substitute this. P, which is equal to I square R T by this T. Okay, by T. So we can cancel this T and T. What we'll get? I square R. So we got the first equation. P is equal to I square R. Okay, now try to recollect whatever the things we have done in Joule's law. What we have done? Actually, we substituted the value of potential difference and resistance using Ohm's law, right? The same way, we know that using Ohm's law, I is equal to V by R. So, power, which is equal to V square by R square into R into T whole divided by T. First, this T and T will get cancelled. And this R, this also will get cancelled. What left? V square by R. So this is the second equation. Then we have to substitute the value for R. Using Ohm's law, R is equal to V by I. So our equation for power is equal to I square R T by T, right? So instead of R, you have to substitute V by I. So I square into V by I into T by T. T and T will get cancelled. I square and I will get cancelled. Last, left with I into V. I into V. So this is the third equation. So we got the three equations for power. So I'll write it one more time. First one, power, which is equal to, we can write work done by time or energy by time or heat generated by time. From this we derived other three equations. Power, which is equal to I square R, then which is equal to V square by R. And the third one, which is equal to I into V. So these are the three equations for electric power. Okay. So I hope it's clear. You have to learn these equations, then only we can solve the problems. Thank you.